Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the kinematics of fluid flow, and in this topic is this numerical problem is based on the continuity equation. Okay, so let's read the problem. The following cases represent the two velocity components. Determine the third component of velocity such that they satisfy the continuity equation. Okay, so this is the first question, this is second part. Okay, so in these two parts we have been given three components. There are three components, u, v and w of velocity, and only two are given, u and v. Here also only v and w are given, so we have to find w here, u, w, sorry, and here u is not given, so we have to find u. So let's see the first problem first. So it is given that u is equal to x square plus y square plus z square, and v is equal to xy square minus yz square plus xy. So we have to find third component. So it should satisfy the continuity equation. So what is the continuity equation? If we consider, we will assume something for simplicity. If we assume that it is incompressible and steady flow. Why are we assuming that? So that our continuity equation becomes simple and this question can be solved. Because if we don't consider incompressible flow, then del rho by del t part will also come in the continuity equation, and if we don't consider a steady flow, then we cannot take rho out. Okay, del rho u upon del x component will be like this. So if we put a steady flow, then this u rho will come out of this differential equation, and del rho upon del t will be 0. So what will be our continuity equation in simplified form? It will become del u by del x plus del v upon del y plus del w upon del z is equal to 0. Okay, so if you are facing difficulty up to here, then I request you to please watch our previous video to understand continuity equation and other basic knowledge. Okay, so here our u is given, so what will be the del rho upon del u? Del u, we have to find this, del u upon del x. Okay, so we will differentiate u with respect to x only. Okay, here only, because it is differential, so it will be variable will be only x, other two components will be considered as constant. So del u upon del x will be del upon del x, x square plus y square plus z square. So these are constant, so del y square upon del x will be 0, and this will also become 0. So it is only x square, so it will become 2x. Okay, similarly del u upon this one, del v upon del y is equal to del upon del y, v is xy square minus yz square plus xy. So it will become, if we differentiate it, then it will become 2xy, because x is considered constant here with respect to y, so x will come out, and differentiation of y square will become 2y, so this will become minus yz square, so differentiation of y will be 1, so it will become only z square, because we are considering everything as constant except y. Okay, plus x. So this is our del v upon del y, this is del u upon del x. So if we put these two in this equation, continuity equation number 1, this is continuity equation for incompressible and steady flow. So it will become del u upon del x is 2x plus del v upon del y is 2xy minus z square plus x plus del w upon del z is 0. Okay, so if we add these two, then it will become 3x plus 2xy minus z square plus del w upon del z is equal to 0. Or we can also take del w upon del z in this side and these 3 on other side. So it will become del w upon del z is equal to minus 3x minus 2xy plus z square. Signs will change because we are taking these on other sides. Okay, so del w will become equal to minus 3x minus 2xy plus z square into dz. So if we integrate both sides, then what will we get? We are integrating only respect to z, so we will get w is equal to minus 3x into z minus 2xy into z plus z square. Integration will be z cube divided by 3. Okay, so I hope you understood up to here. After that there will be a constant of integration c. So this is the component w. So what will be c? C value of c is unknown to us, but we know that in respect to w we are integrating in respect to z, then x and y are also constant. Okay, so c can be also function of x and y or any number also. Okay, so it will become minus 3xz minus 2xyz plus z cube divided by 3 plus c can be written as function of x and y. Okay, because here we integrated respect to z, so when we are doing it with respect to z, then, and this is not it, we are integrating with respect to z, then x and y are constant. Okay, that's why constant can be also a function of x and y. So this is our third component. Now let's see the second part of the question. Here v is given, v is 2y square and w is 2xyz. So what are the continuity equation? Del u upon del x plus del v by del y plus del w upon del z is equal to 0. This is simplified continuity equation. Sorry, this was v. So if we put values here, then here we have v, so we will get del v upon del y. What will be it? Del upon del y into 2y square, so it will become 2 into 2 is equal to 4, y to the power 1 or 4y. Del w upon del z is del upon del z into x 2xyz, so it will become 2xy. Now if we put the values here in equation number 2, then what we will get? Del u upon del x plus del v upon del y is 4y plus del w upon del z is 2xy is equal to 0. So we will get del u upon del x is equal to minus 4y minus 2xy. So we will get del u is equal to minus 4y minus 2xy into dx. If we integrate both sides, then we will get u is equal to minus 4xy minus 2x square divided by 2 into y. So it will become minus 4xy plus c here, constant of integration, minus 4xy minus x square y plus c. Okay, so similarly in case of previous, as we have seen, the c can be function of, we have integrated with respect to what? Dx, so it can be function of y and z. So we can write it as u is equal to minus 4xy minus x square y plus f y and z. So I hope you understood this problem. If you have any doubt, then you can ask in the comment section, and thank you for watching this video.